guys, today we're going to be talking about electromagnets, another super common topic at GCSE. So make sure, grab pen, grab paper and watch this video really closely because these questions are really likely to come up in your GCSEs. So we're going to start with the basics, that if we've got a wire carrying a current, it's going to produce a magnetic field around it. It's just one of these laws of physics, that this is what always happens. If a current runs through a wire, we get a magnetic field, okay? So if we switch the current on, we get a magnetic field. If we turn the current off, we don't get a magnetic field. Okay, so this magnetic field only occurs when we've got charge moving, so when current is actually flowing. Now we can find the direction of the magnetic field around a current carrying wire using our right hand rule. So take your right hand and give me a thumbs up. Your thumb is going to go in the direction of the current. Okay, so in my case, going up, lovely. Your fingers give you the direction of the magnetic field. So the magnetic field will be going round like this. Now, the magnetic field, if we use iron filings to have a look at it, is in these lovely concentric circles pattern like this. And the direction would be going like that, as I can see from using my right hand rule, that the field would be going like that, okay? So these are our basics. Now, if I want to get a stronger magnetic field, I can increase the current. Note that we're increasing the current, not the potential difference, not the resistance, nothing else like that. Increase the current. Or I could coil this wire into a coil like this, called a solenoid. Okay? Now, if I run the current through this solenoid, what's going to happen is that all of those magnetic fields are going to kind of join together and reinforce each other, making a stronger magnetic field. So the shape of magnetic field around the solenoid, around the outside, is very similar to that around a bar magnet. Okay? So we've got these characteristic jacket potato shapes. Inside the solenoid, however, it is a uniform field. What happens is that those lines just go straight through like that. In my video about magnetic fields, you might remember that we talked about how the magnetic field strength can be shown using field lines. So where they're closer together, it's stronger. Where it's further apart, they're weaker. Because these field lines are staying the same distance apart as they go through, it shows that we've got a uniform, which means the same magnetic field. So the strength of the magnetic field is the same all the way through the middle of that solenoid. Now, I want to know which end of this solenoid is going to be the north and which end is going to be the south. So for that, I can look at the direction of the current flow. So we're going to imagine the current is going up on the back and down on the front, up on the back, down on the front, up on the back, down on the front, up on the back, down on the front. I'm going to take my right hand rule again, but this time my fingers are going to go in the direction of the current. So up on the back, down on the front. My thumb will point in the direction of north. So this end will be my north, this would be my south, so I can add field lines to my diagram. Remember, magnetic field lines always flow from the north to the south. So, if I want to make the magnetic field around this solenoid stronger, there are three things that I could do. I can increase the current. I can add more coils, or move the coils closer together. So if I were to bunch these coils up into a smaller area, that would make the magnetic field strength stronger. Or the final thing I can do is I can add a magnetic core, which is usually made of iron. If I put an iron core through the centre here, what happens is that the iron becomes magnetised. Because iron is a magnetic material, and if I put it in the middle where we've got this really strong magnetic field in the centre of this solenoid, it's going to amplify the magnetic field of that solenoid. So the iron's going to become magnetised as well, and we're going to wind up with a stronger magnet. Now this is sometimes known as an electromagnet. So I've got a solenoid and I put an iron core through the middle, I get an electromagnet. Now the main advantage of an electromagnet is that it can be turned on and off. When the current runs, it's magnetic, but if I turn the current off, all those field lines are going to disappear. So this can be really useful if I want something to be magnetic sometimes or magnetic not other times. These are used if we've got electronic door switches. So often there's a really strong electromagnet holding the plate of the door at the top. When you type in the right code or whatever, the electromagnet turns off so you can open the door. We can also see this sometimes when we've got fire doors that automatically release when a fire alarm goes off. And also electromagnets are really heavily used in scrapyards because they can sort out magnetic materials from non-magnetic materials. So there we go. Everything we need to know about electromagnets for GCSE. Now remember that if you want to really improve your chance of getting a really good grade at GCSE, I think the best way to do that is to join in my live lessons. So check out the link in the description of this video if that's something you're interested in. Whilst you're there, you could also subscribe to this channel so I can carry on making videos for you just like this. And if you want the notes on this topic, head to my resources on the My EdSpace website. I'll see you really, really soon. Take care.